At equilibrium, no net reaction occurs. The reaction quotient is equals to the equilibrium constant. So in this case, the E cell is equals to 0. So from our Nernst equation, the reaction quotient here, which is log Q, we are going to change it into log K. So K is our equilibrium constant. So since the E cell is equals to 0 at equilibrium, we can find the value of the equilibrium constant by using this formula, which is E naught cell equals to 0.0592 over N times log K. So for example, the question asks us to calculate the equilibrium constant, which is the K, for the zinc copper cell. So we have the E naught half cell for the zinc and copper here. Since at equilibrium the E cell is equals to 0, so we are going to use the formula E naught cell is equals to 0.0592 over N times log K. So find the value of N by have a look at the half cell equation. Okay, since the E naught half cell for zinc is more negative, so zinc will become our anode and copper will become our cathode. So from here we can see that the number of electron involved is 2, so our N is equals to 2. So substitute the value. Okay, so before that, find the value of the E naught cell. Okay, so we will get the E naught cell value, which is positive 1.10 volt. Okay, so substitute the value. 1.10 equals to 0.0592 over 2 times log K. So K, which is our equilibrium constant, is equals to 1.45 times 10 to the power of 37. So if our voltaic cell is not at standard condition, we are going to predict the spontaneity of the cell by comparing the cell potential value, which is the E cell value. So if the E cell is bigger than 0 or it gives us positive value, the cell reaction is a spontaneous reaction. While if the E cell is equals to 0, it means that the reaction is already at equilibrium, and if the E cell is less than 0 or it gives us negative value, it indicates that the reaction is a non-spontaneous reaction. So for example here, okay, will the following reaction occur spontaneously? Okay, so the question asks the spontaneity of the cell at 25 degrees Celsius if the concentration of the ferrum 2 plus ion is 0.60 molar and the concentration of the cadmium ion is 0.010 molar. So from the concentration here, we can see that this reaction is not at standard state. Okay, so we have to use the Nernst equation and find the E cell value. So since the overall equation is already given, the Nernst equation, okay, before that, just like before, we need to take out the half cell equation because we have to find the number of electron involved. So from the oxidation number here, we can see that cadmium has an increasing of oxidation number, which is from 0 to positive 2. So cadmium will undergo oxidation, while for the ferrum, okay, so the oxidation number of ferrum is reduced. Okay, so ferrum 2 plus ion will undergoes reduction. So the number of electron involved in this reaction is 2, right? So our N is 2. So our Nernst equation is E cell is equals to E naught cell minus 0.0592 over N times log concentration of, okay, so from our overall equation, so remember only aqueous and gas are included in the expression. So since we only have the aqueous phase in this reaction, so log concentration of CD2 plus, which is our product, to the power of 1 divided by concentration of Fe2 plus to the power of 1. So substitute the value. Okay, so before that, we need to find the E naught cell. So our E naught cell is negative 0.04 volt. So since this reaction is not at standard state, so we cannot predict the spontaneity of the cell by looking at the E naught cell value. Okay, so we have to compare the E cell value. So substitute the value negative 0.04 minus 0.0592 over 2 times log concentration of the cadmium ion, which is 0.010, divided by concentration of the ferrum ion, 0.60. All right, so the E cell value is positive 0.013 volt. So since the E cell is bigger than 0, the reaction is a spontaneous reaction.